suppose we're at time. We can go ahead and get started. I like to talk a few minutes anyway, so we'll let people come in if they're running late. It's a little awkward to be so spread out, but it is kind of nice to be back in person finally. It's been a couple years since I've been on site with any events, and even though you're a little ways out there, I still like to. This type of setting is so much easier because I feel like I can actually talk to people. So this is a topic that I'm going to share today that is something I've been working with for a few years now. I used to think I knew something about it, and then I realized how much I didn't know. And as I started to discover more in that area and learn a little bit more about it, I got really excited about all the parts I had not previously known. And so my hope today is that some of you may find a few tidbits, a few nuggets of value that you can take with you as well. And I can share kind of some of the excitement that I've been working with the last couple of years here. If you are not here for the real-time talk using Node and Redis, you will not hurt my feelings if you leave. That is what I'm intending to cover. But if you are here for that, fantastic. I do tend to enjoy much more classroom style. So I do invite, if there's something unclear or there's an area you're particularly interested in, if it's a quick question, feel free to interrupt, raise your hand. And I'd like to do that kind of as we go. If it's a longer question or you want a little deeper dive into something, I'll ask you just to kind of write it down, save it to the end. I'll make sure there's plenty of time at the end for questions as well. This is a very loaded topic. There's probably about 3 hours worth of information we could cover. I will do my best to keep the initial presentation short enough that we have plenty of discussion time at the end. So with that, as every good presentation, I have an obligatory intro slide. My name is Garth Henson. I've been working in, started with very front end web stack years ago. Found myself working down through the stack. I worked at Amazon for a few years, then went to Disney for 6.5 years, and most recently have moved over to Microsoft. And what's very intriguing to me is if I had to describe the areas of the stack that I spend most of my time in, it's the polar opposite ends. It's building and serving last mile JavaScript, scaling, getting CDNs, things like that in place, working with client side JavaScript, and then it's working in the data side. Real-time data, getting it streamed to the front. It's how do we scale the data? How do we make sure things are working? And how do we report on things that are happening in the very front end? So it's been very intriguing to me, especially the last couple of years, to be on the polar opposite ends of the stack and finding how much commonality there is between them. But again, like it says here, please come talk to me. The best way to find out more information, let's just sit and talk. But as we get started, I want to cover for sure, make sure we're all on the same page. What do we mean when we're talking about real time? If you look up the definition, well, we'll get into the definitions in a second, but processing data, obviously, no application is worth much of anything without data. Obviously, the data is what drives it. The data is where the value is. And so we have to determine at what speed our application can continue to function reliably with a good user experience, and how quickly we have to have the data and the story of the data, not just the raw data, but be able to tell our users something with the data we're presenting. And the rules around when that data processing happens or how soon it is needed is what we're talking about with real time. There's 3 different categories, most groupings, I guess you could discuss. You've got real time, and then you've got near real time, and then you have basically your batch data. I think most of us are probably familiar with batch data. This is your MapReduce. This is anything where over time we're doing long-term polls. Actually, sorry, this batch is even beyond that. Most categorizations, MapReduce, 45-minute, couple hour even, is still considered near time, near real time in most groupings. Batch is like your payroll processing, happens bi-weekly. This type of thing where it can wait a long time, do a bunch of data all at one time. Near real time, that would be like your MapReduce. Speed's important. You've got to have the data. It's got to be flowing constantly, but it's not necessary to have immediately. Real time is really what we're focusing on today. Real time is the type of things you need to be able to measure on milliseconds primarily, perhaps seconds, at the outliers, maybe minutes. Okay, this is the data we've got to have very, very rapidly, perhaps have lots of crunching, if the result and the story that you need to process and have available is immediacy, then that's something that we need to have real time for. Example up here, ATM machine. If you had to punch in your PIN code and ask for a withdrawal and it was near real time and you had to wait a couple hours before they could tell you whether or not the transaction was okay, it's probably not good, right? That's real time that we're talking about here. The second thing I want to touch on is the communication paradigm we want to use for our real-time transfer. I think most of us in the room are very familiar with the difference between the push and pull methodology. In our case, we're going to be solely focusing on push. And we're not really going to be talking about long pull. We're not going to be talking about iterative, querying. We're just going to deal with opening connections, pushing messaging, pushing data upstream. So obviously with these two, considering the available technology stacks that can support both communication methodology, but also support the real-time needs is very important. So in this talk, we're going to look at some of the implementation of tools for this. Push, I mentioned methodology makes the most sense in our case. There's a lot of different tooling to do so. Talking specifically about the data flow for just a moment. How many of you, I would expect, shouldn't make assumptions. I have gotten myself in many troubled positions making assumptions of what people are familiar with. I would assume though, everybody in here, PubSub is familiar? Yes, no? Most? Okay, great. So let's just breeze through this really quick. PubSub model essentially lets us to broadcast topics, push topics, or push information to very particular topics. It lets a consumer subscribe to very particular topics and only receive the messaging that we care about. So if you've used anything like Kinesis, that type of thing where you just have tons of data being piped down, they're flagged or they're categorized by topics. And as a consumer, you can specify only the data messages you care about, and then you can do your crunching on just the messages you're receiving, right? It's a fairly common model, especially application architecture. There's a lot of PubSub out there. But one of the biggest things for us, the consumers listen only to the topics they want to. The messages themselves can be persisted in some data store, and then they also can be relayed. That's something we're going to look at as well. And then, or replayed, I'm sorry, not relayed. And then push messaging across sockets is very fast. So especially if you're talking from data all the way through application layer into the client, we're still talking about very, very small duration or latency to get the data all the way through the stack. PubSub, again, this is a very high level. Multiple publishers obviously can broadcast events and data. That's one of the big benefits. So consider, as we're talking real time, we can be telling data stories with aggregating data from multiple sources, right? We're not limiting ourselves to real time just from a particular source. By using this model, we can actually have data streams inbound from multiple applications, multiple sources coming through our event bus. The event bus obviously is going to maintain the connections, it's going to maintain the topics, and it's going to essentially just relay to the consumers. And the consumers or the subscribers obviously will know what topics, or they've subscribed to particular topics, they've defined what they care about, and they're going to get the messages over those topics that they care about and consume only the relevant data. So the reason I wanted to go ahead and do this is because in our model, I'm using Redis essentially as the event bus. Now Redis, how many in here have used Redis or use Redis? Not as many. I was actually hoping it would not be quite as many because there's a few things that are really, really cool about Redis. And if you're not using it, I hope you'll explore it. I was pleasantly surprised as I've been digging into it of the power that's in Redis. I had only used Redis as a good caching mechanism to do some calculations and some basic indexing and things like that for like API calls, being able to cache calculated requests and put them in Redis and have a TTL on the cache key and have it auto expire, things like that. And the more I got into it, I realized that Redis built in from 2.0 on has PubSub already built into it, where you can within Redis publish two topics, and then Redis can actually relay those over the appropriate topics to the connections and the subscribers on it. And so if you then start pairing the data model and the data types in Redis with the Lua scripting that is available to add logic into the Redis layer, and then you combine that with the capacity to be able to do publishing across particular topics, all of a sudden you have this incredibly robust way to both make calculations, store, and publish data over time. So we're going to dig into that a little bit. In our case, again, today, both the API layer that's going to be our publisher is just a node service. It's going to hook into Redis. It's going to serve as the publisher. And then we're going to have another WebSocket service that will run a node layer as a subscriber. That's really all we're going to do for the demo today, but it will show, hopefully, the transfer of data through Redis into another consumer in real time. All right, so again, the way ours is set up is hopefully, again, very familiar. Redis is the center layer. The right-hand side and the left-hand side in this diagram are the publisher and consumer. If a publisher relays a message or publishes a message and there are no consumers that are subscribed to the topic yet, obviously nobody's going to get it. The consumer, it's just going to kind of be a dead message, right? However, by using Redis, one of the things that I have in place is that it will cache that message. It will actually keep a maintained queue of all of the messages that have come through. And we'll talk about data types in just a moment. Redis has a data type that's a sorted set, and it allows you to key your set or score your set based off of an integer or a float value. You can then do lookups, so you can do aggregates, you can do all kinds of things on that with a very, very low complexity query. And so if I happen to reconnect and subscribe to a topic, I can then query based on your last connect time and replay to you any messages that have come through since your last connection. It's pretty cool. We'll look at that a little bit later. So if the publisher sends out a message, let's say it publishes topic number 1, there's nobody listening. So Redis drops it into the queue. It caches the message. Then we have a consumer that subscribes to topics 1 and 2. At this point, we have the option to say, if we built the cache into the layer, that Redis can just say, sweet, we've got the connection. I'm going to replay to this consumer all of the topics since whatever timestamp either they give me or some other criteria, maybe 5 minutes or something, and you can relay those messages. And then at that point, any subsequent messages that come through, any publisher then can publish to either topic 1 or 2, and it immediately can be published out to the consumer, but we can also continue to cache for additional consumers that may connect down the road. All right. As I touched on, Redis is much more than just a cache. Here are just some of the things that Redis can allow us to do. So again, it's kind of nice. It's our data layer and our PubSub all rolled into one. The PubSub support is already native. You literally call publish and you give it a topic and you give it a string and it does all the relay for you. If any consumer has connected to the Redis instance or the Redis cluster and subscribed to that topic, they'll receive it. The cache, in my mind, this is kind of that traditional use of Redis, right? This is that base level key value pairing. You can set it up with an actual expire time. It'll auto expire those keys so that if you're dipping into Redis to like replay calculated values, you can get it if it exists. If it doesn't, it'll auto expire and then your origin can recalculate and recache. You can have really nice streamlined caching out of Redis. That's what I had previously used Redis for, just that layer. However, Redis actually has a lot of built-in data types. The lists essentially are linked lists within the system. It's just collections of string elements sorted automatically by insertion order. So you can use them very easily for queues. You can push, you can pop, you can do all your normal execution. You then have your sets, and this is just your organized collection. It's unsorted string elements. Your sorted sets, this is what I touched on before. This is what we're going to look at in a minute. It's like a set, but in addition to the string value, you're giving it a score. The score is a float value. It automatically sorts everything in the sorted set by the score you give it. If you happen to have something where they share the same score, then it's a lexicographical sorting after that. If I recall correctly, it's an O1 lookup for everything in a sorted set. And the nice thing about it is a sorted set can handle up to 4 billion records in a single Redis sorted set. And so you do the math, we start getting to massive, massive amounts of data we can actually filter through very, very, very quickly. And then the hashes. These are built in as well. These are just our maps that are composed of field associations like you'd expect. The keys and the values both are strings in this case. So you can look up at a root key and you can give it one or more sub keys or keys from the hash and get back very particular values. Now it says in Redis everything's strings. What we're going to look at in just a minute with Lua scripting is you can have libraries in Redis as well that will let you do JSON decoding. You can do message packing. You can do some other things to help compression or sorting. And so you can start being very creative with what you're choosing to store in those timed events and those sorted sets. And you can have some really, really robust message layers here. Oh yeah, this is the one I referred to a minute ago. This is off of some of the documentation. In a Redis sorted set, add, remove, and test for the existence of members is an O1 operation. Constant time regardless of the number of elements contained inside the set. The maximum length of a list is 4.2 billion, 4.3 billion elements per set. I was talking to somebody earlier. There's a conversation I was having with a colleague recently, where if you look at all of the geo IP regions, so lat long combinations, I believe there's 640,000 globally, something like that. If you layer that even 10 times and you're doing some type of global tracking, you could store information at every one of the layers for 10 layers deep. Sorry, not 10 layers deep. What did I have? 5 layers deep, and you could still sort it in a single set with all the data, 10 layers in a global geo IP type thing or geo tracking, lat long. So it's a really massive amount of information. Now, if you know Redis, and something we're not going to touch on today, but something you do have to consider, the data itself is sizable, right? 4 billion records is a lot. And so you have to consider the size of the cluster you're storing in as well. That is a consideration. And that's something that if you're using one of the hosted services or managed services, AWS, Azure, you can have the clusters spun up in a way to manage that side of things better as well. All right, so great, this is all well and good. What about the code? If you have not played with Redis in Node before, it's almost identical to the way you would set up WebSocket connections. You essentially import the Redis client. You can create a new client subscriber, and you set up a listener for the message event that comes through. The message event will be fired for every single event your consumer receives. So the way you throttle that is you only subscribe to the topics you care about, and you can do a client subscribe or unsubscribe to one or more topics. And so if you are doing a particular activity in your API and you need to watch for, I'll give you one example. If you're doing, say, like an end-to-end testing and you're wanting to have a secondary application you're kicking off and it needs to phone home to tell when it's done, you can actually subscribe to a particular topic for the duration of the test. When it pings and phones home, you can unsubscribe from it, and the ephemeral node can be done at that point. So you can have that type of subscription and subscription very, very easily here. Publisher is really the same. Publisher is actually a little easier. You set up the exact same type of client. When you connect, you just provide the topic when you call publish, and then you provide your string, whatever your message needs to look like. In our case here, I just stringify a JSON payload. Then the consumer can receive it. If they do a JSON parse, you can do full transports across Redis in real time like this. Now, here's where I like to get a little bit excited. So I mentioned executing things in Redis. In this case, this example is calling a z increment by command on Redis. So all of your prefixed z commands have something to do with sorted lists. If you're creating a new entry, you can call z add, you give it the score that you want, and you give it the actual value that you're storing in your set. And that's how you create a new entry. This command, though, what it allows us to do is provide the lexicographic value that I want to update. And I can tell it increment or decrement by a particular number, and it will modify the existing score in place and move it up or down in the set. So if you're doing anything with leaderboards or that type of thing, and let's just say you've got like a gaming leaderboard and you have all of your top scores over time, you don't have to know the current score to move somebody in your leaderboard. All you have to do is know what their added score is. If they earned something new, you can call Z increment by, and as long as Redis has the total leaderboard, they can actually modify the score in place and they'll move everybody and resort. And so then you can grab your top 100, top 10, whatever it is, immediately after making a call like this, and you never had to read the value back out. So you can use it much more like a database, traditional database, and do updates in place with some of these commands. So in this case, I'm incrementing leaderboard key. That's the name of the sorted set. In this case is leaderboard. I'm saying I want to increment a +1. I'm putting a vote called my vote, and I'm just pushing that across and then be able to handle the errors or the reply. This makes sense so far? Fairly straightforward, I hope. Excellent. Now, this is where we obviously, back on this one, if you're executing the command, this can get very verbose, right? If you're writing node and you're writing this type of combination and you have to chain any number of commands, this can get really crazy, really fast. The other thing to consider is every execution to Redis does run, and this is something else that blew my mind. Redis essentially runs single threaded. So it's an atomic action that will lock, and it will actually run them in the order in which they were requested. So it's not going to run them in parallel. It will actually stack them. And so if I have multiple commands like this that I need to run in sequence and guarantee them to work together, I either have to batch them as a single Redis action, or I have to write a Lua script, because the execution of the Lua script is the command to Redis, and Redis will lock that thread, run my Lua script, and then release again. So I can run a Lua script in memory on the Redis box, give it enough information to run all the calculations and do everything I need to do, and then either return or even down on line 31 here, publish from within the Lua script. So this is where things get kind of cool to me. The top thing here, first, what is it, 3-4 lines? There's a distinction in keys and arguments that get passed in. This is the one part that I think took me the longest to get my head fully wrapped around. The keys that you're referencing, you cannot just pass in static strings into a Lua script. You have to pass them as keys and let the cluster manage the keys that go into the Lua script. The reason being, if you're in cluster mode, you don't know which cluster is actually, or which node on the cluster is actually going to be the one processing your data. And let's say we had leaderboard was our named key. I don't know what the actual node level index is, because what it needs to do is go to node 3 and look at leaderboard on that node to get the most recent data. Right? Redis is going to do its sharding, and it's going to be able to know where everything is happening. And so what the keys here do, and we'll see in a minute when we execute a Lua script from the client, we pass in the keys, and then Redis will actually do the processing in the cluster mode to then hand it off to the script. So if you ever dump the keys out here on a clustered mode, they're not really readable keys. These are your hash keys for the index that's looking up within Redis. Okay, so that's very different from your arguments. Your arguments are just your execution arguments. This is just like your function calls. So in this case, we give it 3 keys. We want the key for the index that the votes are stored. We want the index for the leaderboard. And then we want the index or the topic that we want to publish to when everything's calculated. Then we pass in 2 arguments. We type in, or we pass in the current timestamp, and we pass in the choice. And in this case, what we're doing is we're saving the vote. This is the script that's going to run in the, hopefully the demo we do in just a minute here. But the choice that was voted upon, okay, gets passed in as an argument. Then what we do is we actually call just push on a standard list. And remember, we said lists are just our sorted set based on the entry position. So we push onto the list the actual full vote log. Okay. That vote log gets put in place. We then call increment by, and on the leaderboard, we increment the choice that was passed in by 1. Makes sense. But then what we actually do is we create a new result table. We loop over, we call reverse range by score, which means I want to read out of my sorted set in reverse order, so max to min. So we're actually pulling back out our leaderboard from the highest vote to the lowest vote. We loop over all of those. We build out our result set. Line 24, 25 is how we actually, in Lua, insert into the table. We get the new pairings in place. Once we have the new leaderboard, so again, we've just saved a vote. We've then extracted the current leaderboard, including our new vote. We then immediately publish it on the topic. So this will publish to everybody who's connected what the current vote count is. So everybody's going to get in real time, every time a new vote comes in, what the new leaderboard standing is. And then it returns to the caller the final result as well. Okay, so that's what this Lua script does. Make sense? Any questions on this one? Excellent. This either means that nobody gets it or it's going really well. Hopefully it's going well. All right. So there's 2 steps to using a Lua script like that in your Redis instance or cluster. The first stage is you actually have to load the Lua script in, because again, Redis, everything's in memory, right? So you're literally loading your Lua scripts into memory, and then you're going to execute them. Once they're loaded in memory, you can call them by hash and say, here's the keys and the arguments, go execute the script I already loaded. This is the Node client to load a new script into Redis. The way Redis will store it is it will actually do a SHA-1 hash of your entire content of your script and return that to you. That hash is how you then reference it in the future to execute it. So that's basically your signature to say, hey, here's my script. Great, got your script. It's in memory. Here's your hash. When you need to run it, use the hash and I'll know which one to pull. It'll just start executing that one. Once it's in memory, we can execute them using the eval SHA command. And this will let us pass in the hash that we were returned. So the actual hash of that script I want to execute. And then here's where things get fun. Remember I mentioned there's a distinction between keys and args that we pass into a Lua script. Because eval SHA can take any Lua script you want, you have to tell it on execution how many of the next arguments are keys. So you have to provide a keys length as your second argument. Then the next n number of arguments you pass into the function are the keys. They're going to be evaluated as keys. So like I said, if you're in cluster mode, this is when Redis goes, oh, okay, these are the keys. I'm going to calculate then what the true index is, pass those into the Lua script so it knows how to read or write those keys. Then the additional props are parsed and passed in as the arguments to the Lua script. Okay, so when we looked at the keys versus args, that's the distinction. You tell it this many of my arguments are keys, the rest are actually arguments, and then you have your handler function to manage any error cases or the results. Make sense? All right. So what we're going to open up in just a moment here, this is the high level architecture of what I've put together. Again, really not very complex as architecture goes. However, for what we're doing, it's a little voting thing. It's a bit over architected for what we're actually going to do, but hopefully it will show all of the pieces in flight. There's a React app. I'm going to give you a URL in just a minute. You'll be able to open on your phone, your laptop, whatever. And I'll show you on the screen a graph, just a D3 graph that will monitor in real time as people vote on different things. It will count them and you'll see the bar graph grow as it comes through. Hopefully, if all goes well on your phone, you're going to have a countdown timer. It's going to stay open for 30 seconds and feel free to tap around, do as much as you want during that time. And at the end of 30 seconds, the final total of everybody's votes on any of the values should show up on your phone right away. And the key being that the connections between the dashboard and your phones or your laptops, those 2 different endpoints, they're not connected with WebSockets. Everything that we do is actually going to be running through the Redis layer and published back out. So we've got WebSocket connections on 2 sides, all fanning out through the pub sub in Redis. Okay, and so again, it should be in relative real time. There's also, and I'll give at the end of the talk, I've got a slide that'll have the URLs for the actual repos for all 4 of these pieces. But the observer piece is just a secondary backend node that is also subscribed to that same Redis cluster, or in this case, it's just a single Docker image. But the observer is able to listen and log things as need be. It's also the one that over time can do a tick and look at the actual logs. So remember, we were pushing the votes based on timestamp and everything into an actual list. This is the type of observer that would be able to go in and read those as well. So, yeah. All right, so if you will, those who care to join us, open this URL, ato2021.guahanweb.com. Hopefully, my AWS instances are still running. You should see something like the left-hand side if you open it up. It may take a second for the connections. When I click start, you should get a selection of 4 options for Pokemon. You choose your favorite one. Yeah, I'll click start in just a minute over here. What'd you say? Yeah, the URL ATO 2021, and I'll spell it. It's .guahan web.com. We have at least a few people that can see this screen yet. No? Too fast. Let me go back to my slide deck. It's going to be easier, hopefully, to see. Let's do this. Ah, I like that sound. Give it just a moment here. While we're here, I'll put a plug in. That's my Twitter as well, if you care to reach out later. Minus the ATO subdomain. Is it looking better? Anyone have it loaded yet? A couple thumbs up. You what? Redirect port 80? Oh, do I have the S? I do not. This is what happens when you actually finally get your CloudFormation template working the day before your presentation. Little things like that are not in there yet. Thank you. So yes, please do put the HTTPS. You'll actually be able to see it in place. All right. Sorry if you're not there yet. We're going to go ahead and kick this off. Hopefully, I'm keeping my fingers crossed. You what? All right, let's see. Well, let me get reloaded here. Make sure I am reconnected. Come on, Wi-Fi. Jake was just saying earlier today, more live demos this year than we've seen in a long time. Come on. Well, hey, there we go. All right. Please work. Hey, yeah, I saw a vote come through. Look at that. Now mine actually froze. There we go. If you refresh the main page, it should retain the current state as well and let you continue while the countdown is going. That was the replay I was talking about. When you reconnect, it will automatically replay the current state back to your device. Wow. My daughter will be very proud that Evie won. That is her favorite. She couldn't decide. I don't know. I'm going to geek out a little bit on Pokemon here. My 9-year-old is a huge fan. And I don't know, what is it? 7 different evolutions that Evie has? I don't know. She first started like telling me, well, you need to have all these. She's naming all of them. I'm like, no, 4, only 4. So anyway, as we said, what happened here was the browser on the standard app side just had a WebSocket connection to the backend. The backend was connected to Redis. It subscribed to the vote topic. That's all it did. When you tap, it's actually sending a WebSocket connection to the backend, the publisher, so the admin side. That side is connected to Redis as a publisher, and it's taking the vote and I'm sorry, it's not connected as a publisher. It is simply executing the Lua script that we looked at with your vote. So Lua is then incrementing by 1 that vote, and then it is processing the Lua script and then publishing out. So for all the connections, and you saw how quickly this was updating. So that was updating on every single publish that every vote was coming in. So as fast as that could come through, was going through that entire system and back through again. And so it was doing the increment, it was doing the aggregate, and then being able to retrieve it. So great, thank you for participating. It was nice to see more than my 15 or 18 that I could actually click with my thumbs. So here are the repositories that we just looked at. Back in Observer, those two are going to be very, very similar. The Observer one right now is actually pretty empty. It just is yet another one that's can pop up. The DevOps here is just a local Docker Compose script that you can just, if you clone all 4 of them by name, just in a location as front end, back end, Observer, and DevOps, you should be able to go straight into the DevOps folder and just run Docker Compose up. It pulls down the latest Redis Docker image, and it spins up a Redis container, and then it links these 3 into that Redis instance. And that's all it does. So the code's all in there. Everything we looked at just now, that is what's running. So you're more than welcome to pull that down, take a look at it, send me messages, tell me what's broken, what I can do better. I always love to learn. This is one of the things I was telling somebody just beforehand. I've been using Redis for a few years, but in the last year or so, I've been doing more of this type of thing, and I got really, really excited about it again. And so being able to share some of this, and for me, if a couple people can go away with more things to try, but I can get people to give me feedback and say, yeah, but have you tried this? That's one of my biggest benefits for doing this kind of thing. So I have about 7 minutes. I wanted to leave plenty of time. Any questions, thoughts, suggestions? Nothing. Yeah. Yep. Right. Right. So if you're running, my understanding, and you're asking a great question, is right at the edge of where I'm clear and where I think I know what's going on. When you run Redis in cluster mode, it's going to, when you call through node and do the connection, it's going to manage where the script gets executed. So you're not connecting directly to those subnodes on your cluster. And so Redis itself in cluster mode is going to distribute the execution of that however it does. And so from everything I've played with, both locally as well as in running it in cluster mode, I haven't had to worry about when I get the hash back, I just call it with that hash again and it executes it. Mm-hmm. Oh, so in this case, though, there's still a single entry point to Redis. Okay, so let me see if I understand what you're saying. One of the limitations, I think, of the design that I have here is it assumes everything that it needs to communicate with, that needs to receive the broadcast, is connected directly to Redis, right? You wouldn't want to do that in production, right? You'd want to have a fanning node that would be subscribed to Redis or be communicating to Redis, and you'd front everything with either API calls or that kind of thing. Is that where your question is? Right. Oh. Right. So no, the beauty of it is that if your code base where your Lua script resides, you can run a SHA hash on the script, just on your box, and it's going to be the same hash no matter which box it runs on. And because it's just a SHA-1, as long as you just grab the hash for the contents of that file, if you hit the Redis cluster and it doesn't recognize the hash, it'll error. But if another node uploaded it, even if you try to upload it again, it's just going to pass you the hash back. And so if you want to call and see if it's there, you can actually call to see if the script exists just by running SHA-1 on the contents of that script, and then hit Redis, and it'll tell you if it's there or not. It's a great question. Anybody else? Yeah, so for me, one of the biggest things was Redis is so fast and the lookups are so quick so just in what we did, there were 3 different executions, right? I had to increment the vote. I stored a log on that list. I pushed the entire vote onto the list. And then I retrieved and built the table for the return set. I published that, and then I returned it, right? So there are 4 actual Redis executions that happened. If I had to call all 4 of those from Node, what I discovered that even the hop, the network time, added enough latency that it was measurable. Because Redis is so fast that even just doing that 4 times was adding, even if you want to say it adds 17 to 20 milliseconds, Redis can do that entire script in like 5 to 7. And so first of all, the speed is tremendous if you can run that. Now, there are going to be limitations. I want to make sure I'm not just telling everybody, just shove everything into Redis. You don't want to bog down your Redis cluster either with a long running script, because Redis runs single threaded, right? So if you hit it with a really long script and you truly are logging it down, you probably need to orchestrate a different way. But the speed that it runs, the other thing is, in our case, I wanted to be able to write the vote and retrieve the current leaderboard before another vote came in. So you're leveraging the fact that it's doing the atomic actions by making sure the Lua script is done before the next one kicks off. Right. So those 2 things in my mind are why moving to a Lua script for something like this is definitely beneficial. Yeah, good question. Anybody else? We got 2 minutes. Yes, sir. Yes. Yes, thank you. So I'm going to go back to this slide. The API to vote goes straight through the backend and into Redis. If you have multiple consumers where you're using Redis to publish real-time data out to clients, you want to be considerate of the number of direct connections you have into Redis, right? Because when you call publish in Redis and it has the broadcast to everything, I'd prefer not to saturate my connections to my Redis cluster just with subscribers. I want to be able to have logical connections reaching in and doing things as need be. And so in a case like that, what I would actually do is on the back end, or maybe the observer is a better one. On the observer layer, I would try to have a single observer instance that is essentially a fanning node, that it opens up WebSocket connections to n number of other true consumers, and it listens to everything and just relays them out based on some other type of subscription. Now, you could very easily turn this into something where you have, let's say you want to do data partitioning of some sort. You may want to have fanning nodes for very particular partitions, right? I may want one, you may even have different groups of your organization that own the consumption of very particular data sets. And you could allow them to have control over the fanning node and beyond for just a couple topics. Then it doesn't matter where the data comes from, they can control it, but you can gate only a single connection to Redis to their first entry point. So I think what I was getting at with initially the question, just really cautiously guard the connections to your DB, and not like, I wouldn't just want to spin up, oh, we need to scale, spin up 15 more nodes, they're all going to connect to Redis now. It's not generally a great approach, right? I don't want to scale at the direct DB layer. I want to scale in a way where I can hopefully distribute further out than that. Does that make sense? Okay, great questions. We are at time. I am happy to stick around and chat longer. Thank you very much for the time. I hope you got something new out of this, something to go explore and experiment with. I know I'm going to keep playing with it. So thanks so much.